Okay, so the second type of circuit is a parallel circuit, which we've already looked at to show the difference between the two. But the main thing, how you know you're looking at a parallel circuit is that the electrons have more than one pathway for the electrons to flow in. So as soon as you see there's a fork in the road or there's a branch off where the electrons can go one way or the other way, you know you're looking at a parallel circuit. Okay, so this is a little bit different from when we were looking at current and voltage in a series circuit. So now it's the opposite. So potential difference is actually the same on a parallel circuit, and it's the current that is going to be additive. So again, this will make more sense once we look at an example, okay? So the first step when you're looking at a circuit is to decide what type of circuit you are looking at. So let's take a look. Let's follow the pathway. So here are the electrons leaving the battery, and here we have a branch off. So there are 3 different pathways that the electrons can flow in. So some will go this way, some will go this way, and some will go this way. And then eventually, actually, if you take a look, they do come back together and go back to the battery. But it's this part here where you have that split off that will tell you you have a parallel circuit. Okay, so now let's look at voltage first, because I think that's a little bit easier to kind of understand here. So I'm going to use different colors to show you the pathways for the different electrons. So let's look at one pathway. I'll use red. So here's the electrons, they're traveling, and let's say we're going to the left. So the electrons will go this way and then return back to the battery, right? So let's look at how many loads that electron or those electrons on the red path went through. So they went through only one load. Did you see that? Let's look at a different color. So let's use a different path. So the electrons are traveling, and let's go down the center path, straight and then back. So let's follow the green pathway. How many loads did the electrons on the green pathway travel through? Again, only one. Okay, so let's look at the last pathway. We'll use blue. Okay, so the electrons are going to be traveling. We're going to the right, and then they're coming back around together. Okay, so let's take a look. How many loads did the blue pathway follow or go through? Only one load. So if you remember what voltage represents, so the voltage at the battery in this case is saying 24 volts. That means that the electrons are spending 24 volts worth of energy as they travel through the circuit. But if you take a look to see the specific electrons, each of them is only going through one load. So that means that all 24 volts are being spent at that one load. So the 24 volts from the battery are being spent here because the blue electrons are spending all 24 on the blue pathway, right? The electrons on the red pathway are spending all 24 volts on this red load because there's only one there. And then the green is spending their 24 volts at the green pathway load. So there's no, like if you look at the example here, the voltage is split because there's more than one load it has to go to. But here, there's only one load that it's using its energy at, so it has to match the energy that is from the battery. So that's the relationship. The voltage at every load on the parallel line is always the same, right? Because they have only one load that it's traveling through. Now, if you look at current, okay, so let me get rid of the voltage, but I'm going to keep the pathways the same, okay? But our focus is going to now be on the current. Okay, so if you remember, current is looking at how many electrons are traveling through at a certain point in a certain amount of time. Okay, so when we were looking at series circuits, the current was always the same, no matter where we went. But now, because there is a fork in the road, you are going to have less electrons on each pathway. So for example, if we were to look at this point right here where my X is, notice that all the electrons are together here. So see how this is 15 amps? That means over here would also be 15 amps. They're still all together. Over here, it's still 15 amps because they're still all together. But as soon as you have this branch off, you're not going to have 15 amps at each spot. The reason why is because you don't have all the electrons going in one pathway. They're taking multiple pathways. This is like, imagine you have a street and there's like 10 cars on this road, and some cars are going to turn left, some cars are going to turn right, some cars are going to go straight. So you're not going to have the same number of cars on the road after some have turned off and some haven't, right? This is the same kind of idea. Think of the little electrons as cars. As soon as there's a split off, you're going to have less electrons on that wire. So, that being said, well, how do we know how many electrons are going to be on each pathway? Normally, you will have information that will help you. So, for example, this is telling us that 9 amps have traveled along this green path. Now remember, there's 15 total. So over here, when they come back together, I also have 15 total. But at this spot, my red, green, and blue do not have 15. I have 9 at my green line. So you're probably wondering, okay, well, let's say, 15 minus 9, I have 6 amps left over. But there are 2 pathways. So because we don't have any other information to go by, you would assume that 3 amps would go to the red and 3 amps would go to the blue. So notice 3, 9, and 3 all add up to 15. Now, if you were told one of them, so let's say we had information about 1, but we did not know information about 3, you could calculate this more specifically. But if you don't know information about 2 of them, you assume that they would split up whatever amps are left over. Okay, so the general rule for parallel circuits is that all of the currents on the different pathways have to add up to the current that's on the main path where the battery is. Okay, so let's look at another example before we get to the comparison. All right, so let's draw something out here. Let's say we had 1 light bulb, and then we had a second light bulb, and here's a switch. Okay, so electrons are traveling, and here's the branch off. Okay, so let's use different colors. Actually, I'll go back. It's nice seeing the difference in colors. You can see the different pathways easier. Okay. Jeez. Okay, I'll make that one red. Okay, so here is one pathway, right, going out of the battery, and then here's our fork in the road, right? So some are going to go down this path, and let's use blue for my other one. We're going to go down, and some are going to go straight. So here's the fork in the road. So some will go left, and some will go straight down. And then eventually they'll come back together. Okay, so let's say the battery voltage, we don't know. And this voltage is 5 volts, and we don't know this voltage here, question mark. Okay, so for voltage, remember that we are looking at how many loads the electrons are passing through. So when we leave the battery and come back to the battery, that will tell us how much energy was used by those electrons. Now down here, if we are told that this light bulb is using 5 volts, that tells us that 5 volts of energy was used in this pathway, correct? So in that case, the red pathway electrons, make this red, The red pathway electrons then would also be using 5 volts because they're also traveling only through one load. So the voltage in a parallel circuit are always the same. Okay, hopefully that makes sense. So let's look at, we'll step away from voltage and we'll look at current. Okay, it's a different color. So let's say the current at the battery was 5 amps. And the current at this load down here was 2 amps. Okay, so remember that whenever there's a split off, these are like cars on one road and then some are turning and going down a different roadway than the others. So because the total is 5 amps when the two paths are together, you know that these two branches should add up to 5. So in this case, the current would have to be 3 amps. So that the red electrons are 3, the blue electrons are 2. So when they come together with red and blue on the same wire, you have a total of 5. Okay, so those are parallel circuits. If it helps you to write down these rules, right? So for series versus parallel, that makes it a lot easier, okay? So let's compare them. So this we already know, right? So we went through this already. So in a series circuit, the current is the same because it was only has one pathway, and the voltage adds up because multiple loads, you're showing all the total electrons that it's going through. The total amount of energy the electrons are spending. A parallel circuit is actually the opposite. Current is additive, which is what we just looked at, and voltage stays the same because remember there's only one load that they are going to. Now, bulb brightness. We haven't talked about this yet. Now, if you're looking at a parallel circuit, maybe I'll use this as an example. So when you're looking at voltage, right, that's the amount of energy the electrons are spending. So when you're looking at a parallel circuit, the electrons are not actually sharing the energy with anything else. So if you remember, we had 24 volts here, and each one of these was 24 volts. 24, 24, 24. So they're always the same. So that means that these, imagine these were light bulbs, they would all be the same brightness because they're not sharing their energy with anybody. Whereas if we were to look at a series circuit, here we had 3 volts and 7 volts. That means these light bulbs, imagine they were all light bulbs for a second, so these light bulbs would not be as bright because the total voltage is split between them. So it's like imagine you are sharing energy with other things. The energy is not going to be as much because you have to share it. Whereas a parallel circuit, you're not sharing the energy at all. Maybe go back to this one. 24, 24, 24. There is no sharing. So that means all of the bulbs will actually be very bright, the same brightness. So in a series circuit, this page is actually really nice for comparison. Okay, so when you're doing a series circuit, each light bulb that you add in will become dimmer and dimmer. Next week, you guys are going to be doing a gizmo activity that's going to show you this as well. So if you have a parallel circuit, the brightness will always be the same, and it actually has to do with the voltage. So here you're sharing voltage. Here the voltage is always the same level, so it's just as bright.